Okay, so before we jump into the teardown, I just want to say, if you don't already own this board, definitely don't buy it. Overall, it's a bad buy. It's not even worth the discounted prices you're finding them on eBay at this point. If you want to skip to just the teardown, go to this time point in the video and you can skip this. But I just want to talk about the board for a second. In short, my friend and I purchased a couple of these boards off eBay for 200 bucks. That's kind of the going rate. These were new other, as it's described by eBay, where they're new, but they're not new from necessarily the manufacturer. So upon getting their boards, charged them all the way up before our first ride, what we found is they really only last for about 1.5 miles to 2.5 miles when they're rated at closer to 11 based on the manufacturer specs. So the only reason I'm even doing this teardown, the only reason I'm interested in replacing these bad battery cells is because my friend is prepared to forfeit his board. He doesn't care to fix it, so I'm going to tear mine apart, test the cells, replace the bad ones with the good ones from his board. Mostly just for fun as a quarantine project. It's not really efficient, it takes a lot of time. This took me about 5 hours to complete, and we both already purchased Meepo V3 boards, so this is really quote unquote just for fun. But if you already own the board and you're having a similar experience, definitely watch on. Hopefully this helps. First things first, you gotta get a socket wrench and a screwdriver or drill. Remove the 4 screws retaining the trucks. Go and remove the trucks and the rubber spacers underneath them. Carefully remove the back truck, keeping in mind that it's still plugged in. Unplug the bullet connectors for the motor. And now you'll want a pry tool of some sort. In this case, I'll just use a flathead screwdriver to separate the battery cells from the board itself. Here's a look at the board with just the truck screws in it. I'm gonna go and put the nuts back on these just to hold them in place until I'm ready to mess with them again. Next step is to remove the foam that's adhered to the battery cells. This is what is between the battery and the board. On one side you'll find this aluminum flap covering a couple holes in the aluminum chassis for the battery cells. This is just to give you access to the charge port and the power button. To remove the plastic end caps, you just have those 2 screws there. Now this side has the board receiver, so I'm going to unadhere it to the plastic end cap, gently remove the plastic end cap, and then move over to the other side. So this side doesn't have any technology, just a couple of screws holding another plastic end cap. It's worth noting though that this board has a fuse in it, and if you wanted to just change the fuse, you would remove this side of the end cap and you get access to a user replaceable fuse in there. Now having a look here, we can see our power button and our charge port. Both of these are held in place with one nut. So you'll have to get in there with needle nose pliers and shimmy that out. You also want to note that on the power button there is what appears to be a little bit of wax on it. You can see here that makes it a little bit more difficult to get that port out. we've got both the power button and the charge port rather, out at this point. And here you can see again that wax. So at this point, our main goal is to force all of the cabling inside of the aluminum chassis so that we can slide out the components. Here I'm just removing the gasket around the cables that go to the motor, just because it makes it a lot easier to get those cables pushed inside without that rubber gasket in the way. Now we're gonna remove 4 Allen screws that are on the top side of the case the part of the case assembly that meets the board, and this is what's gonna retain the computer system. Now, if you're like me and you skip that step and forgot to remove those, what you'll find is that you'll pull out the motherboard afterward, and it will have severed from the battery. And you can see here I'm just putting the screws back into the holes in the computer system just so I don't lose them. You can see here after Captain tape, the board disassembles from its chassis pretty easily. And here you can see where I severed the balance cables from the battery pack by not removing those 6 Allen screws. So here's a look at the battery removed, in case you're interested in simply trying to replace it. Now before proceeding, I'm going to remove the fuse. Now we're just going to go around the battery, remove the factory shrink wrap, because my intent and the whole reason that I took this apart was to break apart all the cells, test each one individually, replace the bad ones, and reassemble it as it is. So the first thing to do now that I have all the tape and shrink wrap removed is just unroute as much of the cabling as I can. Now if I separate 2 of these battery packs, what you're going to find is they're joined by one long strip of nickel, and it's soldered to each cell individually with 2 solder points. So I'm going to remove the battery balance leads. Note there's going to be 1 on each pack of 4 cells. Now to remove the nickel strips, I'm going to do sort of a rotating motion, kind of like I'm balling them up instead of pulling directly away, because I don't want to fail the battery cells, or at least not fail the ones that might still be good. This is going to be a long and tedious process. You're going to need pliers, you're going to need wire snips, and just a lot of patience to get through this part of things. So now that I've got some of the cells removed, I'm going to go ahead and start testing them. So here, anything around 3.6, really 3.5 to 4.2 is good. But you'll see these bad cells, they'll be lower than that, but as I'm getting their reading, they'll quickly fall in voltage until they get to 0 or mostly 0. So I'm going to mark those as dead, give them an X, and put them in the dead pile for recycling. So as I start packing the good ones back together, I'm just doing a quick sanity check, making sure that they are actually good before I start the process of re-welding them together. So here we have the welding machine with just a little bit of pressure holding the nickel plate down on the battery cells themselves. Again, this is going to be a fairly tedious process as we have 24 total cells with 4 welds in total for each one inside this battery pack. And you'll notice I'm leaving a little strip of nickel off to the side. That's to join the cells together once I'm done soldering them. And as I go, I'm just testing each pack after welding it to make sure that the welds are good and it's reporting the correct voltage. So here you can see as I join them, those 2 nickel plates, those tabs that are sticking out are going to come together. I'm going to tape these together with a little bit of retaining captain tape just so I can perform the weld. And again, I'm testing the voltage for both packs together. Here I'm using just a little shim to pressure underneath those 2 tabs to join these 2 packs together. And again, just a lot of rinse and repeat with this part of the process. It took me about an hour and a half to test the batteries, weld them back together, tape them back together, and again testing with each pack and then testing the whole as I add another pack. So with the pack joined back together, now I have to solder back on the battery balancing leads. So what I'm doing here is I'm hitting it with a little bit of flux gel before I lay the soldering down, just to join it a little bit better. Though to be frank, none of these welds are really that good. And just like before, you're going to rinse and repeat. Note that all the balancing leads are white except for one red lead, which is going to join the very top positive portion of your cell pack. As long as you didn't snip these wires too short, they should all come back to where they belong in length and attach to the appropriate battery cell. Now for good measure, as I said, none of these solders are very good. I'm going to tape each solder point down to the battery pack it's joined to in hopes that it doesn't disconnect. And now I'm going to reroute all of the wiring through the little plastic channeling that is part of the cell structure, or rather the retaining cell structure provided by the manufacturer. And so I tried shrink wrapping this, but the shrink wrap I ordered was too big. And I definitely knew that going in, but I was like, I'll just try it. Let's see if it shrinks enough. But it definitely didn't, so you'll see later that I definitely gave up. And decided just to put the batteries in with captain tape over the exposed parts, or at least most of them, with the intent of taking it back apart later when I have the appropriate sized shrink wrap and redoing that portion. But you can see this is just not going great. So then I tried cutting the shrink wrap laterally and removing a lot of the mass, and then just holding it in place with electrical tape. And that seemed to work, and I think with a little bit more effort that may have worked. But the problem I faced later was that I simply could not get it into the aluminum chassis that is underneath the board. There's very little clearance in there, and there's very little tolerance for sort of manufacturing or repair defects. So keep that in mind. And as mentioned, it's just not gonna fit. I tried for quite a few minutes and gave up. And here what I'm doing is just resoldering those balance leads back into the sort of main board. If you didn't sever yours like I did, of course you don't have to worry about this. And just doing a quick check, quick sanity check just to make sure everything still works. And everything's looking good so far. So nothing left to do but to carefully slide the battery cell assembly back into the aluminum chassis. If you're at this step, I would say just make sure that you're putting it in the right orientation, such that the 6 Allen screws are going to line up with the 6 holes in the aluminum chassis. Let those be your sort of guide point to know which direction to put it in and which side it should be, which side should be facing up. And you can see here, even without the shrink wrap, it will barely fit in the chassis. Okay, now that it's in, I'm gonna make sure all of the ports line up, and since they don't, I'm just gonna give it a little nudge in the right direction. Now that's done, reroute all your cables appropriately to their to the physical port that they belong in. And then I'm gonna replace the end caps, again being very careful with that remote receiver so as not to break it. I'm going to remove the nuts that I left on the screws. Remove the screws so that I can begin routing them one by one through the whole assembly. I want to do it this way because I want to be careful not to scratch or sever any of the cables that are inside the assembly. And you can see here in the top leftmost port there is a little bit of cable exposed, but I can work around that. Don't forget your rubber spacers before you put the trucks back on. One more test. Now that everything's put back together, I want to make sure it's actually working. And it's looking good. Last thing to do is to take this as far away from anything flammable, put it on the charger, and let it charge all the way up. So after letting the board charge up for about an hour and a half after putting it back together until both the charger and the board itself gave the full battery indicators, I went for a ride. And what I found is that the board only lasted about as long as it did before this repair, before the charger gave the low battery indicator, or rather before the remote gave the low battery indicator. And that's about 1.7 miles, which is pretty disappointing. It's worth noting that after fully charging the battery and turning it on for the first time, the remote showed that it only had one of well, I should say the remote had one of 3 LEDs turned on, indicating that it was at like I think 20% battery power. So I think this might really be an issue with the balance leads or the BMS on the board. But if anybody's more experienced than I am with this, given that I have basically no experience, I'd love to know what you suspect the problem is, because again, I'm kind of turning this just into a project board for fun. And at this point, I am operating off of the sunken cost fallacy or the gambler's fallacy, and I really want to fix this board. So yeah, if you have any ideas, leave me a comment down below. I'm gonna definitely keep up with the comments to try to get this board figured out. But anyway, thanks for watching.